Hey students, these are the notes for triangle similarity theorem, section 7.4. I am going to be using highlighters, so go ahead and grab your highlighters to take notes with. Okay, so we're going to talk about three theorems that are given to us that allow us to show that two triangles are similar. I want you to recall that when we had congruent triangles, we had 5 theorems. Remember, we had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. And you guys should, when you read that chart, you should feel pretty confident about that chart because you know those. You know how to identify them. You know how to write proofs to show that those triangles are congruent. Pat yourself on the back because you're pretty confident in that. Well, if you're pretty confident in this, you should be confident in this because there's only 3 ways to show similar triangles. So remember, sorry, I forgot what I was doing. Remember, similar triangles are same shape, different size. It's a dilation. So some of these wouldn't work for what we're doing, but there are 3 theorems that do work for us. They are side, side, side. Now, how do I know the difference between this one and this one? Is I have to put the little similarity symbol after it. Okay, then we have side, angle, side. And I have to put the similarity symbol after it. And now we are going to actually have angle, angle similarity. Okay, before, angle, angle was not a way to show that two triangles are congruent, but it is a way to show that two triangles are similar. Okay, so let's just go over these theorems. You can write the words in as I read. If 3 sides of one triangle are proportional, that means they have a scale factor. Let's write that down. Oops. Okay, they're proportional. They have a scale factor, SCALE. If 3 sides of one triangle are proportional to 3 sides of another triangle, then the triangles are similar. And this would be side, side, side. We will have to show 3 ratios to prove this. So the way we're going to verify it mathematically is to show the 3 ratios have the same scale factor. All right, number 2, if 2 sides of one triangle are proportional to 2 sides of another triangle and their included angles are congruent, then the triangles are similar. Okay, now remember, the definition of similar figures are figures that have a scale factor, but the angles are congruent. The sides are proportional, the angles are congruent. So side, angle, side, you're looking for a pair of congruent angles. Sometimes when the triangles overlap, it's a reflexive shared angle. Okay, but one angle in each triangle, and then the sides surrounding the angle. It's an included angle. All right, the third one, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Oh, I forgot to go back up here. I'm going to write it right here. You will have to show 2 ratios and 1 angle. Okay, so that's what the work to verify for this one. For this one, you will have to show 2 angle pairs. Okay, so you have to show 2 angle pairs. In reality, you will have 3 angles that are congruent in one triangle to the other 3 angles, because if 2 angles are congruent, the third angle is automatically congruent. That is actually called the third angle theorem that we have kind of seen before. We haven't ever really used it. So if you accidentally put AAA, it's fine. It's no big deal. You don't have to have the third A because we have the third angle theorem, but we do have to have at least 2 angles congruent in one triangle to the 2 angles in the other triangle. Okay, so this is just kind of breaking down and showing you what you have to give me. All right, it says, name 2 pairs of congruent angles in exercise 4 and 5 to show that the triangles are similar by angle, angle. So for these problems, sometimes you will have markings only, and sometimes you will have angle measures. Okay, so sometimes you will have parallel lines and you'll have to draw the markings in the picture. Sometimes you will have vertical angles and you will have to mark those in the picture. So regardless, I need to see that you have seen two pair of angles. I need to see that you have seen two pair of angles. And the way we're going to do that is we're going to use highlighters. Okay, so in this first picture, I have seen that those are congruent. In this second picture, I have seen that those are congruent. And this is pretty obvious because they gave us the markings, but where this is more important that you use the colors is when you have to put the markings in. The only way I know what you know is by you highlighting and putting the markings in. Okay, so this would be angle B is congruent to angle Y. Angle C is congruent to angle Z. And we're not going to have to do this pretty much in the work. The work's going to be a little bit different when we get to it. Okay, in this picture, I've got the 37s. And don't forget, you've got the 90s. Those are angles. If you wanted to, you could have put, what, 52? 50, 60, 70, yeah, you could have put 52 right here and you could have highlighted those two angles instead of the 90s. It doesn't matter. As long as you show me that you have seen two angles, then I know that you're using angle similarity. So angle T is congruent to angle D. Angle V is congruent to angle F. Okay. Now, I want to also tell you about this problem. Please be careful. If they gave you the 37 here and the 52 here, you would need to find the other angle measures in the triangle to verify that you do have the same angles because they will try to trick you. All right, next. So this is an example of angle similarity. Okay, next. So this is what side is going to look like. We are going to make ratios, and we're going to see that the ratios are congruent in all three parts. Okay, so how do we pick what goes with what? You are going to put big with big, little with little, and middle with middle. Okay, and this is where I use my colors. So the only way I know what pieces go with what is I know the biggest one over here, which is 12, has to go with the biggest one over here, 24. If you don't like using colors, you could circle the 12 and circle the 24. You could underline, let's say the 6 is the smallest. You can underline the 6 and you can underline the 12. Just show me something that you know what goes with what. And also, your third color could be no color if you wanted to stop right there with the colors. But I like just to have all the colors. So what we're going to do is we're going to put yellow over yellow, pink over pink, and orange over orange wherever it's fitting. So let's start with GH. GH is actually pink. So we're going to put 6 over 12. Now, you guys, that's easy. 6 over 12 reduces to 1 over 2. I can see in this picture that it's 1 over 2, but we're verifying it by showing this. Okay, next, HI. HI is orange. So that is 9 over KL, which is 18. Again, it's not going to be this easy for you all the time. And I know that's 1 to 2, which is fine. We're actually going to also be letting you look at these as decimals because that sometimes makes your life easier if you want to get through the problems quicker. And then GI and JL must be yellow. So we're going to put 12 over 24. And I know that is 1 to 2 as well, which is also 0.5. Now, if at any time when you're trying to prove side similarity, if at any time you get 2 of these that are not the same, you do not have to find the third one because you right there have negated it. You know that it's not going to be similar. Basically, what you're asking in the problems, is it similar? That's a yes or no question. And how is it similar? and then give a triangle congruency statement. So I'm going to go ahead and show that to you now. The triangle congruency statement, if I name this first triangle any way I want to, GIH. Remember, doesn't matter how you start, it matters how you finish. So if I go GIH, that's yellow, orange. I have to follow in the same pattern and go yellow, orange. JLK. And that shows all the parts that go together. GI went with JL. You can see it right there in this similarity statement. Okay, so this is an example of side similarity. You will have to show me 3 ratios unless you get 2 of them that are not equal, then you can stop. You don't have to show me the third one. For angle, you have to show me 2 pairs of angles, okay, in the picture. Use highlighters, use some kind of marking, circle them, put boxes around them, whatever. Highlighters are the best thing to do this, but you have to show me 2 pairs of angles in order to get credit. Okay, let's look at side, angle, side. So this is going to be an example of side, angle, side similarity. So I need to put big with big. That's how I know what goes with what. Big with big. And then for this one, there's only 2 sides, so I've got little with little. All right, so I'm looking at the yellow, I'm looking at the pink, and I'm asking, is there an angle in between those that is congruent? You don't have to mark the angle, but you do have to make sure that it is shown in there. And I do have right angles, so I know that I am going to be able to have side, angle, side, provided that the proportions work out. So the congruent angles are angle Q is congruent to angle T. You won't have to write that down. It'll be in the picture. So now we're going to put PQ, which is the pink. So 8/10. Now, this is where you can reduce. 2 goes into 8 4 times, 2 goes into 10 5 times, or you can take your calculator and you can put 8 divided by 10 in your calculator. I actually like using the calculator, and I'll show you when we get to a bigger problem than this, because you can see all of the numbers right here in your calculator, and you can see if it's yes or no. Still got to write down the ratios for me. Okay, so if I put 8 divided by 10, it's going to give me 0.8. And so and I knew that's what that was. So you're looking to see that either both of these are equal to 4/5 or they're equal to 0.8. Okay, so this is yellow over yellow, so I have to put 16/20. And then obviously 4 goes into 16 4 times, 4 goes into 25 times. They are the same. And so when you see that they are the same, you know that it is side, angle, side. Okay? For side, angle, side, you have to show me 2 ratios, and then the angle should be in the picture. You can mark it, just mark it inside the picture. You don't have to write it down. Okay, flip over. This is going over the theorems again. So I'm going to show you what I would expect your homework to look like. And of course, just remember, because you're honors, there's going to be some problems in your homework to make you think, and they would be a little bit more advanced than the ones you're seeing here. Okay, so angle, I am looking at this problem, and I see right away that I have a 75 and a 75. There's one pair of angles. I do not see another pair of angles, but I'm going to get the other pair just to make sure. So 75 plus 74 from 180 leaves me 31. So I have the 31 here, and I see that I have a 31 and I have a 31. Okay, so by me writing the 31 in the picture, showing you with colors or some kind of markings, if you did this, that is you showing me that you saw the angles and you didn't want to use color. I'm not going to make you use color. I'm just telling you color really helps us. So I have to have some kind of marking to show that the angles are congruent and that you saw 2 pair. So this is yes. Side, oops, sorry. angle, angle, similarity. And if I asked you to write a triangle congruency statement, let's say I named this triangle CAB, just trying to mix it up. How would I name this triangle if I went CAB? That's orange, yellow, no color, orange, yellow, no color. So that would be triangle FDE. Okay, question number 2. This is an example of a problem that has no numbers, so you have to rely on the markings that we've had. Well, this problem already has those angles marked. Heads up, if those angles were not marked, but you had parallel markings, you would mark them because they would be alternate interior. Do not mark these angles if you don't have parallel lines. So that we don't have parallel lines marked. That's why they went ahead and gave them to us. You cannot, in this picture, mark these two congruent yet. Okay. You can't think that you can't draw the Z because we don't have the parallel. You can only draw the Z when you have those parallel lines. But I do have this, vertical angles. That's all I need. I only need 2 pair. So we would say yes by angle, angle, similarity. And if I name this triangle WVX, similar to, no color, pink, orange, no color, pink, orange. Okay, see how the colors help you name them with that? Even the triangle similarity statement, the colors help. So this is what I expect from you for angle, angle. The only thing I think that you might see, remember, if you have overlapping triangles, this is going to be one of your angles. So it will be shared. It will be something you can mark automatically. Maybe if you had parallel, you would have corresponding. And there's your 2 angle pairs. So the little triangle is similar to the big triangle because you have 2 pairs of angles. So just know if they're overlapping, you will count this as a shared reflexive angle. Okay, side, side, side. So this is what I expect from you. Either mark with some kind of marking, or you can put the little tick marks. Even though the tick marks show congruence, not similarity, you gotta be careful with that. So I do know that this is the biggest number, and this is the biggest number. It kind of looks like a hypotenuse. Well, we don't know if it's a hypotenuse. It is. It is because this is called a Pythagorean triple, 3, 4, 5. If you check that with the Pythagorean theorem, it forms a right triangle. Just a little free information. So I know those go together. Those are the smallest. And then I know those go together. Okay. So this one is pretty basic. You can say 2 times 5 is 10, 2 times 3 is 6, 2 times 4 is 8. I know this is similar. You would still have to show me the ratios. Put orange over orange, pink over pink, yellow over yellow. And I know all of those reduce to 1 over 2. So, you didn't even need to pick up your calculator for that. So this would be yes by side, side, side similarity. And then we're going to focus more on number 4. But if I were to write a triangle congruency statement, by the way, if you get no, you can't put an answer. You can't put a triangle similarity statement. You can't put an answer here. You can't put an answer here if you get no. If you get no, you move on. Okay. So if I said triangle PRQ is similar to triangle that goes pink, yellow, so it would be SUT. Okay. So biggest with biggest. I also want to let you know, sometimes these are twisted, flipped, turned, and this side does not always correspond to this side the way it's oriented. You always have to pick the biggest, put it with the biggest. Make sure you are looking at the numbers. Okay, the smallest over here is 30. The smallest over here is 24. And then last, that's the middle with the middle. Okay, so we are going to put pink over pink. And I always go left over right, left over right. You can go right over left, right over left, right over left. Be consistent. If you go left over right, make all of them be left over right. We have to be consistent with our work. So pink over pink, orange over orange, and yellow over yellow. Now, you can try to reduce these in your head and get the same fractions. That's fine. But I just want to show you that if you are in the mood to be quick with your work, this is all you have to do. 30 divided by 24, 35 divided by 28, and then 32 divided by 25. Okay, 32 divided by 25. So if you're looking at this, these triangles are not similar because this one didn't match the other two. Okay, so this would be a no, and we move on. You cannot put no if you didn't show me what you did. Okay, all of this work, you can't guess. You have to show me your thinking. Even though you put these in a calculator, this little X right here told me that you noticed one of them didn't match the other two, and so you crossed it out. You have to show me something that you're doing to show me that you did the work. Okay, but this is our first no that happened on the problem on the worksheet. Okay, all right, last, let's look at do that in just a minute. Side angle sides, let's go through these quickly. So I'm looking at, usually with side angle side, you can tell by the way it's oriented, unless it is the bow tie problems. Be careful with the bow tie problems. Make sure you match up the big with the big and the little with the little. So I'm putting 8 over 6, and I'm putting 20 over 15. Okay, and those give me the same ratio. And so, by the way, if I asked you for the scale factor, you have to reduce and give me the scale factor. Okay, so if I asked you for the scale factor, it would be 4 to 3. But if we're just checking the ratios, that's all you've got to see. They are the same. This is yes. Side, angle, side, similarity. Triangle JKL is similar to triangle MNP. Okay. All right, here's one where they're overlapping. So this is my angle that we're sharing. Just like up here, the angle is already marked. It's probably going to be marked for you unless they're sharing it. And we are using this piece and this piece. Okay, because you have to have the small triangle represented and you have to have the large triangle represented. Be very careful with that. Don't use a little piece right here. We have to represent the big triangle and the little triangle. So I am checking 15 over 25. If you put 25 over 15, that's fine. Just be consistent. And I am checking 12 over 21. If you put 25 over 15, then put 21 over 12. These are not similar triangles. Okay? Got it? Okay, that's all the notes. You will jump in and you will do the worksheet that goes with this unit the next day that I see you. Thanks, students.